Hello, Prepare for Honors students. This lesson's on solving systems of 3 equations and 3 variables. You guys in Math 1 solved systems of equations with two equations and 2 variables. Now we're moving on to 3 equations with 3 variables. Just to kind of get an idea of what we're talking about, in example 1 here, right? In example 1, instead of just having an x and y, now you look, we have 1 equation, 2 equations, 3 equations. Then you have an x, a y, and a z. So you have 3 equations with 3 variables. Now, a solution to a system of equations is basically an ordered pair that makes both equations true, while a solution to a system of 3 equations with 3 variables is an ordered triple that makes each equation true. Now, when we go to solve these, right, our goal is going to be to break this system down to a system of 2 equations and 2 variables. So example 1, determine if 1, 4, negative 3 is a solution to the system. Well, in order to determine this, what we're going to do is we're going to say x is 1, y is 4, z is negative 3. If this is a solution to the system, then that ordered triple should make all of these equations true. So I'm going to plug this in. 2 times 1 minus 4 plus negative 3. Will that equal negative 5? Well, 2 minus 4 minus 3, that gives us negative 2 minus 3, negative 5 equals negative 5. That one checks out. Next one, if I do 5 times 1 plus 2 times 4 minus 2 times negative 3 equals 19. Is 5 plus 8 plus 6 going to equal 19? 19 equals 19. That checks out. And the last one is 1 minus 3 times 4 plus negative 3 going to equal negative 5. 1 minus 12 minus 3, does that equal negative 5? Well, negative 11 minus 3, that is not equal to negative 5. That one's ruined it. So 1, 4, negative 3 is not a solution. Okay? Now the next one. I'm going to go through this one a little more quickly, right? So with this, if we plug the ordered triple, negative 1, negative 2, 5, into the first equation, 4 times negative 1 is negative 4, plus 2, plus 15, does that equal 13? Well, negative 2 plus 15 equals 13. 13 equals 13, that checks out. The next one, if you look at this, negative 3 plus 5 equals 2. Does 2 equal 2? Yes. When I plug it into the third one, is negative 1 minus 6 minus 10 can equal negative 17. Well, negative 7 minus 10. Negative 17 equals negative 17. Checks out. Therefore, negative 1, negative 2, and 5 is a solution. Okay? So now, here's where we go into how do we find the solution. Well, I kind of like drafted up these steps here, right? And the steps say basically our goal is going to be to break the system of 3 equations with 3 variables down to 2 equations in 2 variables. To do this, we're going to pick 2 equations to eliminate 1 variable. Now, we're going to duplicate this process in step 2, picking 2 different equations, but 1 equation will be used twice in this process. You want to plan ahead. What variable would, what 2 equations would allow us to eliminate the same variable? So here, if I look at this, if anytime I have just like a 1 in front, that tells me like if I wanted to eliminate the y here, I can eliminate the y using these 2 equations real easily, but I could also use these 2 equations to eliminate y also. So what I'm going to do is pick the first 2 equations, right? I'm going to pick these 2 equations, 2x minus y plus 6z equals negative 4. Then I'm going to take this. So this would be 6x plus 4y minus 5z equals negative 7. Now what I'm going to do with this, if I multiply this top equation by 4, right, that would give me 8x minus 4y plus 6z, plus, 8x minus 4y plus 24z equals negative 16. I'm going to keep the bottom equation the same. And right now, what you notice is the reason I multiplied the top equation by 4 is so that now that creates opposite coefficients here. Negative 4 plus 4, that tells me the y's are eliminated. And I would get 14x plus 19z equals negative 23. So next, right, I'm going to use one of the same two equations. I figure the top equation and the bottom, because I'm looking to eliminate y's again, and I think using those 2 equations would eliminate y fairly easy. So I'm going to write the top equation down, 2x minus y plus 6z equals negative 4. The bottom equation, negative 4x minus 2y plus 5z equals 9. Now what I'm going to do is I'm going to multiply this. I have to eliminate the y's. So I have a negative 2y on bottom. Can I turn the top equation into a positive 2y? Well, to do that, I'm going to go ahead and multiply by negative 2. Negative 2 times 2x is negative 4x. It's going to give you plus 2y minus 12z equals 8. Then carry the bottom one down. Negative 4x minus 2y plus 5z equals 9. That would give me negative 8x minus 7z equals 17. So now if you look at this, I have this system, or that equation, and that equation, and if I put those together, now 14x plus 19z equals negative 23, negative 8x minus 7z equals 17. So now I'm going to go ahead and solve this system of 2 equations in 2 variables, but now I'm going to solve for x and z. If I take the multiples of 14, right? 14 times 1 is 14, 14 times 2 is 28, right? 3 is 42, 4 is 56. If I take the multiples of 8, right, it's 8, 16, blah, 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 all the way to 8 times 7 is 56. So the common, right, multiple is 56. So what I'm going to do is multiply this top equation by 4. That's going to turn that into a positive 56, which means I have to turn the bottom coefficient into a negative 56 by multiplying by 7. So remember, I have to multiply everything by that. So it's going to give you 56x plus 4 times 19 will give you 76. Z equals 4 times negative 23 is negative 92. Then negative 56x, right, minus 49z equals 7 times 17 is 119. And now the x's eliminate. 76 minus 49 is 27. Z equals negative 92 plus 119 is 27. And if I divide by 27, Z is equal to 1. Now I'm going to plug that back in to find the x value. I'm going to plug that into the second equation here. So negative 8x minus 7 times 1, because I'm replacing z with 1, equals 17. So negative 8x minus 7 equals 17. Add 7. Negative 8x equals 24. Divide by negative 8. And x is equal to negative 3. So we have x, we have z. Now all we have to do is find y. Doesn't matter which equation you go back to. I'm going to take the middle equation. So 6 times x is negative 3 plus 4y minus 5 times 1 equals negative 7. So negative 18 plus 4y minus 5 equals negative 7. Combine like terms here. 4y minus 23 equals negative 7. Add 23. 4y equals 16. Y equals 4. So my ordered triple solution would be x is negative 3, y is 4, z is 1. And that is your solution. All right, for the next example, when I look at this, again, there's many ways you can approach these, okay? And if I look at it, would it be easy to pick two equations at a time and eliminate one of the variables, right? If I pick these two equations, I can eliminate x's very easily. Y's aren't hard and z's aren't hard, but it's more work. Then if I look, can I take any other of these equations and use it with this equation to eliminate x's also? Well, I could use the middle and the bottom. Now, if I wanted to, I could also use, right, these two equations to eliminate y's, right? And then I could use these two equations to eliminate y's. It doesn't matter which way you go, as long as you make it easy to use all three equations and eliminate the same variable. So if we went with the route of eliminating x, okay, here's what I'm going to do. I'm going to kind of do it in like more of a established way. I know if I want to eliminate the x's, I'm going to use this equation here, which stays the same. 4x plus 2y plus 3z equals 1. But what I have to do is turn this coefficient into a negative 4, right? X. So what do I have to multiply that by? Negative 2. So negative 2 times 2x is negative 4x. It's going to give you plus 6y minus 10z equals 28. Now, the x's eliminate, and I get 8y minus 7z equals 29. Now next, I have to use this equation. And I'm going to use that equation and the middle equation. So I'm going to keep the bottom equation the same. 6x minus y plus 4z equals negative 1. But now I'm going to multiply this top equation. I need to turn that 2x into a negative 6x. So I'm going to multiply everything by negative 3. So that would give me negative 6x. Negative 3 times negative 3y is plus 9y Negative 3 times 5 is minus 15z equals negative 3 times negative 14 will give you 42. So now, if you notice, the x terms eliminate here, and negative 1y plus 9y is 8y. It's going to give you minus 11z equals 41. So now I can go ahead and take this equation here and this equation here, put them together. So 8y minus 11z equals 41. 8y minus 7z equals 29. I can now take this and solve the system of two equations with two variables. If I multiply this top equation by negative 1, that would turn this into negative 8y plus 11z equals negative 41. And I'm going to keep the bottom equation the same because now the y's will eliminate when I add them together. That would give me 4z equals negative 12. So z is equal to negative 3. Now that I have z equal to negative 3, right? 8y minus 7 times negative 3 equals 29. 8y plus 21 equals 29. Subtract 21. 8y equals 8. Y is equal to 1. I have z, I have y. Now I have to find x. So I'm going to take the top equation from the original equation. And now 4x plus 2 times y is 1. Plus 3 times z is negative 3 equals 1. 4x plus 2 minus 9 equals 1. 4x is going to give you minus 7 equals 1. Add 7. 4x equals 8. Divide by 4. X is equal to 2. And our ordered triple for a solution is x is 2, y is 1, z is negative 3. All right, so I'm not going to make you watch the steps to this whole problem. I'm actually going to give you the solution is 1, 3, negative 2. I prefer you guys to go try this one on your own and see if you get 1, 3, negative 2. If you do not, you can come back and watch the explanation. Don't feel obligated to watch the entire rest of the video. Okay, so the solution is 1, 3, negative 2. If you got that, you're good to go and work on the homework. If not, right, simply listen to the steps for this problem. Okay, for this example, I like to keep my numbers small. And if I look, right, I have a positive z here, which means I could use that middle equation real easily to eliminate z in these two equations. But then I could also use this equation to eliminate this z real easily. And that's exactly what I'm going to do. So what I'm going to do is I'm going to multiply. I'm going to use this top equation. This top equation is going to stay the same. 3x plus y minus 2z equals 10. The bottom equation, right, I'm going to multiply, or the middle equation, multiply by 2. So that's going to turn to 12x minus 4y plus 2z equals negative 4. And right away the z's eliminate, and I get 15x minus 3y equals 6. So what I'm going to do is I'm going to bring that equation down here. 15x minus 3y equals 6. Then I'm going to use the middle equation again. And if I look, I have a 1z and a 3z. I'm going to multiply the middle equation by negative 3. So that's going to become negative 18x, right, plus 6y minus 3z equals 6. The bottom equation now, because I'm using these two equations, is going to stay the same. X plus 4y plus 3z equals 7. Now, z's eliminate here, and I end up with negative 17x plus 10y equals 13. So, negative 17x plus 10y equals 13. Now, I'm going to go ahead and use elimination here to solve this one. I think it's easier right away to turn the y terms into a negative 30 and a positive 30y. I'm going to multiply this top equation by 10. Oops. And the bottom equation by 3. That would give me 150x minus 30y equals 60. Then the bottom equation would become negative 51x plus 30y equals 39. So I would get 99x equals 60 plus 39 is going to give you 99. When I divide by 99, I get x is 1. So I'm going to use that now, right? I'm going to take the top equation, 15. I'm using this equation here, 15x minus 3y equals 6. I'm going to replace x with 1. So 15 minus 3y equals 6. Subtract 15. Negative 3y equals negative 9. Divide by negative 3, y is equal to 3. So now, finally, I'm going to take the x value and the y value. I'm going to plug it into this bottom equation. It doesn't matter which one you plug it into. So I'm going to take the x plus 4y plus 3z equals 7. Now, that would give me 1 plus 4 times 3 plus 3z equals 7. 1 plus 12 plus 3z equals 7. It's going to give you 13 plus 3z equals 7. Subtract 13. 3z equals negative 6. Divide by 3, and z equals negative 2. And my ordered triple solution would be x is 1, y is 3, z is negative 2. Go ahead, try the homework, check your answers, and let me know if you have any questions.